Okay, AMP1 students, in this video we are going to talk about acids and bases. The first thing that we want to cover is water and why it's considered neutral. And so why is it considered not an acidic solution or a basic solution, but considered a neutral solution? So whenever water dissociates, when it dissociates, so here we have a water molecule, and some water molecules will dissociate or break down. And when it breaks down into a hydrogen ion that has a positive charge, and then a hydroxide ion that has a negative charge. So it's going to have one hydrogen ion and one hydroxide ion. So since it has equal amounts of hydrogen to hydroxide, it is considered neutral. Or another way to express that is it has a pH of 7 on our scale of 0 to 14. So the reason that it has that neutral pH or pH of 7 is because when it dissociates, you get equal numbers of hydrogen ions to the hydroxide ions. Okay, so in our body, we're 65% water. So when we have substances added to our water in our bodies, depending on what they are, they can change our neutral water solution and make it more acidic or more basic. So we're going to talk about how it does that. Okay, so I'm going to show you some pictures that I think will help. That'll work. Okay, so here's a picture showing hydrochloric acid. Most people are familiar with hydrochloric acid. That is the acid that is in our stomachs. It's produced by the cells that line our stomach, and then it's inside our stomach compartment. And so the hydrochloric acid, when it is placed into, so here's our hydrochloric acid, hydrogen atom bound to a chloride ion. When we place it into water, so there's a little thing of water, what happens is the hydrochloric acid completely breaks down or dissociates in water. So remember, water's neutral, have equal numbers of hydrogen ions and hydroxide ions. So then we put hydrochloric acid in there, and immediately, remember the little hydrogen bonds of the water molecules, they're going to form around the hydrogen and around the chloride, and they separate them and break them apart, disassociate them. So then what we have now is this water solution that used to be neutral, and now it has more hydrogen ions, this shown 4, than it does hydroxide ions. So when we have that situation where we start to increase our number of hydrogen ions, we start calling that type of solution an acidic solution. So it's become acidic in this case. Okay, so then I'm going to show you in the next picture, I couldn't find a great picture for this, but so we're going to look at a molecule called sodium hydroxide. So sodium hydroxide is considered a base, a very strong base. And when it's placed into water, which this isn't showing our cup of water, but pretend there's a cup of water over here representing our body. When sodium hydroxide is placed into water, what will happen is it will completely disassociate as well, just like the strong acid hydrochloric acid did. And so you'll have sodium with little water molecules surrounding it, and hydroxide with little water molecules surrounding and dissociating or separating them. So what you have in this case is these little hydroxide ions that go and bind and form a bond with the hydrogen ions that were already in the water solution. And so whenever you bind hydrogen ions and they're not anymore freely floating by themselves, you are taking them out of solution. And so what happens is then your number of free hydrogen ions drops, and you have more of the hydroxide ions in that case. And so that's what we call a basic solution, when you have more hydroxide ions and less hydrogen ions. So that will happen when you have a base added to water or to your body. All right. So let's go back here. So I'm going to go to our objectives, make sure everybody is familiar with which ones we're talking about in this video. So we talked about why water is neutral, and we talked about the difference between an acid and a base. So specifically how it reacts in water, in a neutral water environment. We'll also do their definitions. And then I'm going to just define more pH, because we haven't really got to that yet, and explain how the pH values are assigned and why. So we'll go back to our... Okay, so when we're talking about an acid is a substance that dissociates in water, which we saw the hydrochloric acid do. And when it dissociates, it produces a hydrogen ion and then an anion. So we used hydrochloric acid, so chloride was the anion. And then what that causes is the acid that's put into water increases the number or concentration of hydrogen ions that are free in that solution. So they have to be free and by themselves, just like this, in order for them to have an effect on the acidity or pH of the solution. So because the hydrogen is a proton, so it's a proton, it doesn't have an electron, they call it a proton donor. It's kind of donating hydrogen ions to the solution. So whenever we do that, like I said, we get more hydrogen ions than we do hydroxide ions when we add some sort of acid like hydrochloric acid to pure water. So what happens is the pH is measuring the hydrogen ion concentration. So whenever we have, and it's inversely related, so whenever we have more hydrogen ions added to water, that's going to cause an acidic solution, and what happens to the pH is that it decreases. So it'll decrease on our scale is 0 to 14. Pure water was 7. So if anything is considered acidic, it's going to be anything less than 7. So somewhere between 6.9 and 0. So you can see hydrochloric acid is on this list, and it has a pH of 1. If we just had like pure hydrochloric acid, it has a pH of 1. So very acidic. And you can see over here hydrogen ions on this pH part of the scale, pH scale, are increasing, and the pH is decreasing, so it's inversely related. So if the hydrogen ions are increasing, the pH number is decreasing, and you have more hydrogen ions than hydroxide ions in an acidic solution. And then the opposite will occur with a basic solution. So if we have a basic solution, if we add like sodium hydroxide to water, and you get the dissociation of sodium from hydroxide, and then the hydroxide starts to bind and form bonds with the hydrogen ions, that kind of decreases the amount of free hydrogen ions. They're now bound. So we have this decreasing amount of hydrogen ions. But what happens to the pH is that it increases. And we get this solution that has more hydroxide ions than it has hydrogen ions. So this number will be anywhere from 7.1 to 14 in that case. And you can see sodium hydroxide's down here. All right. So that is our description of acids and bases. And so in the next video, we're going to talk more specifically about organic molecules. So far we've been just talking about the inorganic molecules, water and the electrolytes, non-electrolytes, those kind of things. So now we're going to focus on the organic molecules in the next video. So I'll see you in the next video.